Hi, welcome to our next application video for differentiation. In this video, we're going to talk about how to find maximum and minimum turning points. Remember, maximum and minimum turning points are points on the curve which have a zero gradient. A maximum occurs when the gradient changes from a positive gradient into a negative gradient. And a minimum is a point on the graph where the gradient changes from negative into positive. At both of these points, y dash or dy dx or f dash x all are the same thing for gradient function must equal 0. All right, let's get into example 1. This is a level 2 type question, but let's remind us how to do it before we move into a level 3 type question. Find the turning point for the function y is equal to x squared minus 3x plus 5. Well, let's work out y dash first. So x squared differentiates to 2x, minus 3x differentiates to minus 3, and the plus 5 disappears. So here's our gradient rule. Now, we know a maximum or minimum is when the gradient rule is equal to 0. So we're going to take the gradient rule, 2x minus 3, and put it equal to 0. Let's rearrange it and put the minus 3 on the other side. So 2x is 3. And divide both sides by 2 to get x is equal to 1.5, or 3 over 2. Right, when x is 1.5, we're going to go back and put that into the y rule. So y is equal to 1.5 squared minus 3 times 1.5 plus 5. And we're going to get a y value of 2.75. So we've worked out the x and the y coordinate. So here's our function, and we have worked out that the minimum occurs here, and this is at the point 1.5, 2.75. That's the coordinate of the turning point. So let's get into example 2. This is now starting to get into level 3 work. So find the x coordinates for the turning points of the function y is equal to 10x squared times e to the power of 2x. Well, this is a product function. 10x squared has been times by e to the power of 2x. So we're going to call 1g and 1h. We're going to work out g dash and h dash. And we're going to use the product rule to differentiate this function. So y dash is equal to 10x squared times 2e to the power of 2x plus 20x times e to the power of 2x. Now, we are going to tidy this up because this is going to make it easier for the next couple of bits. So we're going to get 20x squared times e to the power of 2x plus 20x times e to the power of 2x. Notice they both have an e to the power of 2x in them. So we're going to factorize out the e to the power of 2x out the front. Right, now we know that a turning point occurs when the gradient rule is equal to 0. So what we're going to do is put the gradient rule equal to 0. And when we have two things times together equal to 0, either the first thing, e to the power of 2x is 0, or the second thing, 20x squared plus 20x equal to 0. Looking at the first part and knowing what the e graph looks like, e to the power of 2x is this kind of exponential or power graph. It never touches the x-axis, which means it will never get to 0. So we can ignore this first part. So let's go to the second function. This is just a quadratic. And when we solve quadratics, we're going to use the quadratic formula, which is on our graphics calculator. And we're going to get two solutions. So here are x1 is 0 and x2 is negative 1. Right, well here's a picture of what this crazy function looks like. And we have worked out that there are two turning points, one when x is 0 and one when x is negative 1. Here are the two turning points where the gradient is equal to 0. Now notice the question asks for the x coordinates, which is what we've found. If we had to find the y coordinates, we'd go and substitute the x coordinates into the y rule. Great, Thanks for watching.